There's something happening at the bottom of the Grand Canyon that is rewriting geology textbooks as we speak. 3 weeks ago, a USGS field team running routine LiDAR surveys along the inner gorge picked up an anomaly so large they assumed it was an instrument error. They recalibrated, ran it again, same result. Then they called Washington. Because what they were looking at was an 89-mile-long fracture, splitting the canyon floor apart. 89 miles? Let that land for a second. That's roughly the distance from Los Angeles to San Diego. Nearly a third of the entire Grand Canyon's length. And it's not a hairline crack. In some sections, this thing has opened to over 14 feet wide, with no visible bottom. The geologists who found it, people who've spent their entire careers studying this canyon, are using a word they almost never use. Unprecedented. Let me give you the context that makes this so disturbing, because the Grand Canyon isn't just any landscape. It's arguably the single most studied geological formation on the planet. Scientists have been mapping it, drilling it, sampling it, and modeling it for over 150 years. We know its layers like the pages of a book. At the top, you've got Kaibab limestone, about 270 million years old. Then you descend through the Coconino sandstone, the Hermit shale, the Redwall limestone, layer after layer after layer, each one older than the last. And at the very bottom, forming the inner gorge where this fracture has appeared, you hit the Vishnu basement rocks. These are metamorphic formations, schist and gneiss, that are approximately 1.8 billion years old. Let me say that again. 1.8 billion. With a B, these are among the oldest exposed rocks on Earth's surface. They've survived continental collisions, supercontinent breakups, ice ages, and everything in between. And now they're cracking open. Whatever force is doing this isn't small. Now here's where I need to get a little technical, but stay with me because this is the key to understanding why the scientific community is so rattled. The Grand Canyon sits on the Colorado Plateau, a massive block of continental crust that covers parts of Arizona, Utah, Colorado, and New Mexico. For most of modern geological history, the plateau has been considered one of the most stable crustal blocks in North America. It's not like California, where you've got the San Andreas Fault and constant tectonic activity. It's not like the Cascades, where subduction drives volcanism. The Colorado Plateau just sits there, rigid, stable, predictable. Or at least that's what we thought. Over the last decade, a growing body of research has been quietly challenging that assumption. Dr. Carl Karlstrom at the University of New Mexico, and this guy is one of the foremost authorities on Grand Canyon geology. He's been studying it for over 40 years. His team has been using GPS geodesy to measure how the plateau moves relative to the surrounding terrain. What they've found is subtle but significant. The western margin of the Colorado Plateau is experiencing extensional strain. That means it's being pulled apart, slowly, millimeters per year. The kind of motion you'd never notice in a human lifetime. But the fracture that just appeared? Dr. Karlstrom told the Arizona Republic last week, and I'm quoting directly, "This is unlike anything in the modern observational record of continental interiors. The rate of surface deformation implied by this fracture exceeds our models by at least 2 orders of magnitude." 2 orders of magnitude. That means it's happening roughly 100 times faster than their best predictions. 100 times. So the obvious question is, what's driving it? And this is where the investigation gets genuinely fascinating, because the easy answers don't work. First theory that got thrown around: reactivation of the Bright Angel Fault. That's a major fault system that runs roughly north-south through the canyon. It's ancient, Proterozoic age, and it's been largely dormant. The fracture does follow a similar general orientation in some sections. But when the mapping team plotted it precisely, the fracture diverges from the Bright Angel trace by as much as 6 miles in places. It's not following the old fault. It's making its own path. Second theory: volcanic. And there's actually historical precedent for this one. Vulcan's Throne, a syndicone right on the canyon rim near Toroweep, erupted as recently as 73,000 years ago. Lava literally poured over the rim and dammed the Colorado River. So volcanic activity in the Grand Canyon isn't ancient history. But seismic monitoring stations across northern Arizona have not picked up the type of harmonic tremor signals that typically precede magmatic movement. The fracture isn't behaving like a volcanic fissure. No elevated gas emissions. No thermal anomalies on infrared satellite imagery. Whatever this is, it doesn't appear to be magma. The third theory, and this is the one gaining the most traction among the research teams on site, involves something called lithospheric delamination. I know that sounds complex, but the concept is actually pretty intuitive. Beneath the crust, you've got the lithospheric mantle, a thick layer of dense, relatively cool rock that forms the underside of tectonic plates. In some regions, that layer can become gravitationally unstable, too dense, and it starts to peel away, sinking into the hotter, more fluid asthenosphere below. When that happens, the crust above it loses support. It thins, it stretches, and it cracks. Dr. Amanda Hughes, a geophysicist, at Caltech's Seismological Laboratory, published a paper just 8 months ago suggesting that the southwestern edge of the Colorado Plateau might be undergoing exactly this process. At the time, it was theoretical. Now she's on a plane to Arizona because that 89-mile fracture might be the first surface expression of a deep mantle process that's been building for millions of years. And get this, the fracture isn't static, it's growing. Satellite INSAR data, that's interferometric synthetic aperture radar, which measures ground deformation down to the millimeter, shows the fracture has extended by roughly 2.25 miles in the last 19 days. And it's widening. The average opening rate across the monitored sections is about 3 centimeters per day. That might sound small, but in geological terms, that's screaming. Rocks don't move like that unless enormous forces are at work. Now let me bring this down from the science and into the reality on the ground, because people live here. People work here. People depend on this place. The National Park Service moved fast. 23 miles of inner canyon trails are closed. That includes the Bright Angel Trail below Indian Garden, the entire Tonto platform traversed through the affected zone, and the corridor down to Phantom Ranch. Phantom Ranch itself, the only lodging at the bottom of the canyon, a place you have to win a lottery or hike 7 miles down to reach, has been fully evacuated for the first time since it was built in 1922. Colorado River rafting permits through the fracture zone have been suspended indefinitely. Commercial outfitters who run multi-day canyon trips are looking at cancellation costs in the tens of millions of dollars for this season alone. But the human impact extends way beyond tourism. The Havasupai tribe, the people of the blue-green waters, have lived in the Grand Canyon for over 800 years. Their reservation, centered around the stunning Havasu Falls, sits within the canyon system. Tribal leaders have expressed deep concern about groundwater disruption. The springs that feed Havasu Creek, which sustains the community and its world-famous waterfalls, originate from aquifers that could be directly affected if the fracture alters subsurface hydrology. Tribal Chairman Thomas Sayuja Jr. released a statement calling the fracture a threat not just to our land, but to our identity as a people. That hits different than a data point. And then there's the Colorado River itself. It flows directly through the fracture zone. Right now, flow gauges at Phantom Ranch and downstream at Diamond Creek are showing normal readings, which is a good sign. But hydrologists with the Bureau of Reclamation are watching closely. Because if that fracture intersects the river channel and opens a subsurface drainage pathway, similar to what we're seeing at other sites around the country, you could lose river volume underground. And the Colorado River isn't just a scenic waterway. It supplies water to 40 million people across 7 states and Mexico. It fills Lake Mead. It runs through Hoover Dam. The entire water infrastructure of the American Southwest is downstream of this fracture. I'm not saying that's going to happen, but the fact that it's even on the table as a scenario tells you the scale of what we're dealing with. So what's being done? The response has been the largest rapid deployment earth science operation in the Grand Canyon's history. A joint team from the USGS, Caltech, the University of New Mexico, and Northern Arizona University has installed a network of fiber optic strain sensors along 31 miles of the fracture. These sensors can detect micro-movements in real time, down to fractions of a millimeter. Portable broadband seismometers have been helicoptered to the canyon floor to monitor for any deep seismic activity that the regional network might miss. NASA's Jet Propulsion Laboratory has tasked satellite passes, specifically over the canyon, to provide continuous INSAR coverage. And the International Continental Scientific Drilling Program has submitted an emergency proposal to drill 2 deep boreholes, one inside the fracture zone and one outside it, to sample rock conditions and measure temperature gradients that could confirm or rule out the delamination hypothesis. But here's the honest truth. Right now, the scientists don't have answers. They have hypotheses. They have data that's coming in faster than they can model it. And they have a fracture that's still growing. Dr. Karlstrom, when pressed by a reporter about timelines, said something that stuck with me. He said, "The Earth doesn't operate on our schedule. This fracture could stabilize tomorrow. It could propagate for another 100 miles. We simply don't have enough data yet to forecast its behavior with confidence." That kind of candor from a scientist of his stature isn't reassuring, but it is honest. And right now, honesty matters more than comfort. If you're planning a trip to the Grand Canyon, the South Rim and most of the North Rim remain open. The closures are limited to the inner canyon zones I mentioned. Check the NPS website for real-time trail status updates before you go. If you live in a community that depends on Colorado River water, and that's most of the urban Southwest, there's no immediate threat to your supply, but this is a situation worth watching closely. Understanding these patterns isn't just about one canyon or one crisis. It's about recognizing that the ground beneath us is more dynamic than we've been comfortable admitting. The Grand Canyon has been a symbol of permanence for as long as humans have looked at it. What's happening now is a reminder that even the most ancient, most solid-seeming things on this planet are still in motion. If that kind of deep analysis interests you, this channel is where you'll find it. Subscribe for more, and I'll see you in the next one, where we're going to break down the science of lithospheric delamination, what it is, where else it might be happening, and why it could reshape our understanding of how continents evolve. That one's going to be a deep dive. Don't miss it.